Our objective for today's lesson is to be able to explain the difference between tectonic plates and earthquakes. And as I'm reading along, try to look for either my handwriting or either look for this little red laser here. So we're starting off with tectonic plates. Up here, up top, we have the lithosphere. That's the crust plus the upper mantle. And that's just the outer layer, the solid outer layer, the part of the earth, the soil. The formation of the earth is the result of the geological processes over time. So that's how this formed, geological processes over time. Geology is the study of physical and atmospheric features of the earth. Again, this is the lithosphere, that most outer layer right up here, the solid outer part of the earth. And then next we're moving on to lithospheric plates. That's part of the earth's crust that's constantly moving. You can see those denoted here in the picture by the orange lines. They're called tectonic plates. They can't be seen because they're covered by soil and grass and mountains and hills. You also can't feel them moving because they move so slowly. They move slowly, like you know how you can't feel your hair growing and you can't feel your nails growing? That's about how slow the plates are moving. You can see plates on the map above along with the faults in the Earth's crust. See all of the plates on this map above. Earthquakes. This is California. California is in the way out west. It's way out west. It's where the movie stars live, or some of them live anyway. This is a map of this. This is just a map of the state of Alabama. It's a hot spot for earthquakes. It's because California rests on two different plates. The plates are moving against each other, and this is the San Andreas Fault, and it is the most popular, the world's most popular fault. All right, so you see what happens here, the San Andreas Fault. We have this line right here that's running all the way, and let me make it a different color so you can see it better. The red line, I'm making it a white line now, that's running all along the westernmost part of California. I just made it again with my white line. That is the San Andreas Fault, okay? And this is what happens. Everything from right here over the right, that's the North American tectonic plate, okay? And then everything this way and over, this is the Pacific tectonic, okay? This is the Pacific tectonic, and I actually wrote right there, but that should be to the left. Everything to the left of the San Andreas Fault is called the plate tectonics, Pacific tectonic. All right, so the San Andreas Fault is the point between the Pacific Plate and the North American Plate. These two plates cause earthquakes as they are moved and shifted by the pressure beneath them. The most famous California quake occurred in 1906. It was so massive that it was felt as far as in North Oregon and as far south as Los Angeles and as far east as Nevada. Okay, so again, this is the San Andreas map. The red map shows a trace of the San Andreas Fault. The arrows show the directions of the relative motion. So you see this arrow here? This arrow, let me make it white, going down this way. Everything from the North American plate tectonic, they're running south, okay? And then everything over here on the Pacific tectonic is running north. So when those two rub together, that's what causes earthquakes. Most earthquakes occur when stress that builds up in rocks along active faults, such as the San Andreas, is suddenly released, sending out seismic waves that make the ground shake. The pent-up stress results from the friction caused by tectonic forces that push two plates of rocks against each other. All right, so what type of fault is the San Andreas? Again, this is the San Andreas. The San Andreas Fault is a transform fault. Imagine placing this gives you a good visual. Imagine placing two slices of pizza on the table and sliding them past one another where they are touching along a common straight edge. Bits of pepperoni from one side crumble across the boundary onto the anchovy side. So the same thing happens with the fault. And the geology and the landforms along the mighty rift are extremely, extremely complicated. All right, so if you'll look over here to the left-hand side, over here over here where it says geology, where you see the van or the SUV, you can see a plate boundary. The photo of the San Andreas Fault near Gorman, California, showing rocks of a Pacific plate. Gray rocks on the left-hand side of the fault, and then the North American plate are the tan rocks on the right side of the fault. There are very few places on Earth where you can see two plates in contact like this.